Hello friends, this video on aldehyde ketones and carboxylic acid part 8 is brought to you by examfear.com. No more fear from exam. This is the hydration of alkynes. So all the alkynes except ethyne. Undergo this reaction. So when you pass through sulfuric acid, maybe 40 to 50% sulfuric acid, in the presence of HgSO4, that is mercuric sulfate, at 333 Kelvin, you get ketones or aldehydes. So I'll just write alkynes. When you pass through, so 42% H2SO4 in presence of HgSO4, you get ketones or aldehyde. And the temperature has to be 333 Kelvin. So let's see the reaction mechanism. For example, I have my RC triple bond CH. This is my alkyne. So what happens is I have this 42% H2SO4 and HgSO4, and I heat it. So what will happen is this H plus will try to attack this to form a carbocation. So if you see, this bond will break in this fashion to form a stable carb, because this bond, triple bond, can break in this fashion or this fashion, right? But if you break in this fashion, you get a stable carbocation as per Markovnikov rule, and this H plus will be attracted by this. So what you get is RC plus double bond CH2. This is a stable carbocation, correct? And then I have water here. So water will come here, H2O will have lone pair of electron. It will attract this, attracted by this plus charge. It will attack on this plus charge, and what you get is RC double bond CH2, oxygen OH and H. Positive charge comes on oxygen, and oxygen doesn't like the positive charge, so it will break actually. So you'll get this directly. I'm writing this correctly because with this charge, positive charge cannot come on, or let me draw this one more step so not to confuse you guys. Positive charge comes on this oxygen, it is not happy, right? So this bond will break and H plus will come out. So what you get is this guy, correct? Now magic will happen. Now let me draw the structure once again. Right, now magic will happen. Now what will happen is this H will break. So again it will break in this fashion. It will get a slightly negative charge, and this will also break in this fashion, right? So this gets a negative charge, this gets a positive charge. They'll form a bond, and this H plus will attack here. So this carbon will attack this guy. It will be in this fashion. Hope you understand. See, this bond will break, and this carbon will get a slightly positive charge, slightly negative charge here. And this bond will break. So H will become H plus and O minus. So O minus and C plus will form a bond, and this H plus will attack this guy. So what you get is R C double bond CH3. This is what you get, correct? So this is the mechanism for this reaction. So if you want, I can take one example. For example, if I take CH3, C triple bond CH, so again in this I do the same thing, almost 40% H2SO4 and HgSO4. So what you get is CH3, C double bond CH3. This is my propanol. This is what you get. So by hydration of alkynes, we can easily get ketones or aldehydes. The next is by heating calcium salt of carboxylic acids. Let's see this method of preparation of aldehydes and ketones by heating calcium salt of carboxylic acids, also called distillation of calcium salt of carboxylic acids. So generally what happens is you take this calcium salt of carboxylic acid, you heat it very hard. What you get is calcium carbonate. Why you get this? Because calcium carbonate is very stable compound, very stable compound. And generally, how do you get this? I won't be giving you the reaction mechanism, but I'll just give you a fair idea of how it works. For example, I have CH3, or let's suppose R, any calcium, RCOO minus 2Ca. This is my plus 2. This is my calcium salt of carboxylic acid. Right? Now in this case, if you see RCO minus Ca is there. From this, if you take out CaCO3, what happens is there are two of these, right? So typically, if you see the structure of this calcium salt of carboxylic acid is something like this. Let me draw this. Calcium OCOOR OCOR, right? From this, if you want to take out calcium carbonate, CaCO3, you have to take out CaCO3. This much, correct? This is CaCO3. So if you see this, CaCO3 is this, right? So from this, if you take CaCO3, what you get is this. What you get is RCOR. This reactions happen at a very high temperature, so there is no reaction mechanism, but just understand the logic here. CaCO, from this, you're taking out CaCO3, Ca, C, and 3 oxygen. So what you get is RCOR. Correct? Now, if you have a methanoic calcium salt of methanoic acid and one calcium salt of non-methanoic acid, what you get is aldehyde. Correct? And if you have calcium salt of non-methanoic acid, you get ketone. For example, in this case, if I have, for example, I'll just show you. If I take this guy minus Ca, correct? And this, I have to also add CH3, or let's suppose take this only, right? And if you heat this, what you get is CH, you'll get HCOH plus CaCO3. So you see this is nothing but methanol aldehyde. Here, if you take one of these as again my methanoic calcium salt, another as non-methanoic calcium salt. So in this, what you get is CH3COH also. You get other compound, you'll get CH3CO, CH3 also, but you'll get this also, one of the products, right? You'll get a lot of products. And now if you take only the non-methanoic salt, for example, this case, right? And if you heat this, CaCO3 will come out, and what will be left is CH3CO, CH3. It's correct. If you see from this, if you take out CaCO3, you get this. So you get aldehydes, you get ketones. So if you take methanoic salt or calcium salt of methanoic acid, you get aldehydes. You get calcium salts of non-methanoic acid, you get ketones. And if you take combination of these, for example, here this is the combination of calcium salt of methanoic acid, calcium salt of non-methanoic acid, you get aldehydes also, you'll get ketones also, you'll get a lot of product. You'll get 3 products actually. Correct. So remember, the reaction mechanism is not important here. What is important here is, given the reactant, you should be able to take out CaCO3 and form a product. And why you take out CaCO3? Because CaCO3 is very stable compound. It's very stable compound. The next is, we'll try to prepare aldehyde and ketone from Grignard reagent. So here, just understand that if you take hydrogen cyanide, then if you get hydrogen cyanide, So what you get is aldehyde. And if you take any alkyl cyanide, what you will get is ketone. I'll explain this just since this is critical, so I'm writing in top. Now let's see the reaction mechanism. Let's see for aldehyde. So I have to take Grignard reagent. The Grignard reagent, you know, is RMgx, where R has a negative charge and this guy has a positive charge, right? It's slightly positive charge. And if I take HCN, because for aldehyde I would take HCN, HC triple bond N. Correct. Now what will happen is nitrogen is more electronegative, it try to attract electrons itself. Carbon will get slightly positive charge, nitrogen will get slightly negative charge. This positive charge, this R is R minus, so R minus will attack this carbon, and nitrogen, this bond will break and nitrogen will attack this MgX. So what you get output here is my C with the H. This double bond will break into double bond, and this carbon will get my R, and this nitrogen will get my MgX. Correct. So once I am done with this, I need to put water in this. Now if I put water in this, what will I get is aldehyde. So if I put water in this, let's see what happens. So just for simplicity, I'm assuming water has H plus and OH minus ion, right? So this bond will again break in this fashion. Nitrogen is more electronegative, so this will get a slightly negative charge and will get a slightly positive charge. So OH minus will attack this carbon and nitrogen will attack this hydrogen. So what you get is HC, this becomes OH here, this is N, we have H, MgX, and I have R here. This is what you get, correct? Assuming my HOH breaks in this fashion. Now, what will happen is this nitrogen will try to come out, correct? So what will happen is this OH bond will break and you get a double bond here. So let's see the reaction mechanism. Let this be OH here. So OH will go off in this fashion, right? H plus will go off. So this will be a negative charge, and this guy, this bond will also break, right? So this bond will break in this fashion so that this gets a positive charge here. This bond will break in this fashion, and this hydrogen, nitrogen will get negative charge, and this nitrogen will attract this hydrogen. So with this, what you get is R, C double bond OR, sorry, this is H, HC double bond R, the double bond here. Why? Because this bond will break, it will have a negative charge, this bond will get, carbon will get a positive charge. So oxygen negative charge, carbon positive charge will form a bond, and this nitrogen now has hydrogen, 2 hydrogen, and MgX. Correct. Now again you add water to this. So just assuming water is H plus OH minus, just for simplicity. So again what will happen is this nitrogen, since it has lone pair, it will attack on this H plus, and this bond will break actually. This bond will break in this fashion. So what we'll get is this will become NH3 and this will become NGX, and here OH will come. This bond breaks, correct? And this is what you get. So total you get is RCOH, and this is my aldehyde, and this came when I have used HCN. So if you see, if I use HCN, I get, so this H is my, this H. So instead of H, if I use R here, I get R here, correct? Let me show you one real example for aldehydes. So let's suppose I have this CH3MgI is my Grignard agent, in that I use HCN. So what you get is CH3COOH, right? This is what you get, plus NH3 plus MgIOH. Similar reaction for ketones. For ketones, if you see, I have my RMGX, and then instead of using SCN, I'll use RCN. So what you get is this bond breaks, and let's suppose it's R dash. So you get R dash C, R comes here, R minus MgX plus, you get this MgX, correct? And on this, if you add water, you get R dash C double bond O R. This is my ketone plus NH3 and MgXOH. Reaction mechanism exactly similar to what we have discussed just now, right? So for example, I can show you an example. I have CH3MgI is my Grignard reagent. It reacts with CH3 C double bond N, and what you get is CH3 C, here you get CH3 double bond N and MgI. On this, if you add water, what you get is CH3 C double bond CH3 and MgIOH plus ammonia. This is the reaction mechanism for preparing aldehydes and ketone from Grignard region. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.